are made, known as the ribs. Thin strips of maple or sycamore are soaked, then pressed against a heated bending iron to curve them. Then strips are glued around a form, connected at the top and bottom corners with small blocks of wood. Everything is clamped together, allowing the glue to dry for 4 hours. Next, thin strips of wood, called counter ribs, are glued onto the edge of the ribs. This enlarges the surface so that it's easier to glue the ribs and the back together. The violin's front, or belly, is constructed from a solid piece of spruce. A support bar, called the bass bar, is glued to the underside. Sound escapes through 2 curved slots, called F-holes. The violin's neck and scroll head are carved from a piece of maple. Which is then glued to the body. The board is sculpted from ebony, a hard wood that's durable enough to withstand centuries of violinists' fingering. Using a tool called a peg-hole reamer, the violin maker gouges out holes for the ebony or rosewood pegs around which the strings are wound. The wood is coated with 4 or 5 coats of varnish, depending on the colour, and is polished with several coats of oil over several days, until the finish is shiny and silky smooth. Next, the sound post is inserted. This little pine cylinder conducts sound and supports the belly against bowing pressure, so it's critical to position it in precisely the right spot between the belly and the back. It's not glued, but rather wedged into place. The bridge isn't glued either. It's held in place by the pressure of feed through the ebony tailpiece and wind onto the pegs. The bridge has little notches in which the strings sit. The violin is now finished. The bow is made from horsehair and a high-quality Brazilian wood called Pernambuco. The hairs are bound at one end with strong sewing thread, then burnt and sealed with wax to prevent fraying. This end goes into the frog, the wooden box at the bottom or heel of the bow. The frog is covered with a mother-of-pearl lining. Then a ring made of nickel, silver or gold is slipped on to prevent the hairs from tangling. Next come the screws that control the tension of the hairs. The hairs are combed to make them parallel, then inserted into the tip of the bow, known as the head. The screw is tightened until the hairs are taut. Finally, rosin, a sticky tree resin that keeps the bow from slipping off the strings, is applied. Cat. Coming up in How It's Made, nuts and bolts. They are the life force of metalwork and hold together everything from cars to food processors. And toilet paper, a bare essential that's only been around for 150 years. Welcome back to How It's Made. Later we look at toilet paper, a newcomer to the world of hygiene. But first, at How It's Made, we pride ourselves in of how everyday items are made. So it's about time we visited a real nuts and bolts operation. They are the life force of metalwork and hold together everything from cars to food processors. Nuts and bolts are made from what's called steel wire rod. After spending up to 30 hours in a furnace to soften it enough to be worked, the wire rod goes into a bath of sulfuric acid to remove any rust particles. It's rinsed in water, then coated with phosphate, a chemical compound. This prevents the steel from rusting before the bolt forming begins, and lubricates the steel to make forming easier. The bolts are formed by cold forging, shaping the steel various dies at high pressure. The forming machine first straightens the wire rod, then cuts it into pieces slightly longer than the bolt length. The extra will become the bolt head. Each piece goes through a die that makes it perfectly round. Then through a series of dies that progressively shape the head of the bolt on one end. The machine heads up to 300 bolts per minute. Here's what it looks like in slow motion. The die creates a slight collar. The next one turns it into a round head. Then the last one transforms that into a hexagonal head, the most common shape. Next, the machine forms the opposite end of the bolt. A tool called the pointer shapes the bottom of each bolt, creating what's called the chamfer, the part the nut catches onto. Here's the bolt before and after the chamfer. The bolt needs threads to enable the nut to screw onto it. Once again, they use the cold forging method. High pressure rollers press in the thread pattern as we see here in slow motion. This is the actual speed, up to 300 bolts per minute. During each production run, several samples are taken to verify dimensions. Various measuring devices are used, a micrometer to check the bolt's length, calipers to measure the width of the head, and a ring gauge to check the threads. To make the nuts, a process called hot forging is used. Steel bars are cut into small pieces, known as slugs, then heated to 1200 degrees Celsius to make them malleable. As we see here in slow motion again,